So question 7, determine algebraically whether the function is even or odd or neither. H of x equals the cube root of 2x cubed plus 3. It's harder to tell by exponents because there's this cube root in here. So I'm not really 100% sure how that affects the graph. So I do know that even functions, we have what's called y-axis symmetry. And odd functions have point symmetry, or we call origin symmetry. So if I want to graph this, y equals, clear that off and do the cube root. So if I hit the math button, cube root is number 4. If I type in 2x squared plus 3. Again, if I graph it, notice it does have y-axis symmetry. It is mirrored across the y-axis. So the y-axis kind of divides the graph in half. So you kind of see each mirror like graph going in the other direction. So just by looking at it from a graphing perspective, I would have to say it's even. If I want to prove it, h of x has to equal h of negative x. So again, h of x is equal to the cube root of 2x squared plus 3. So if I do h of negative x has to go in place of x. So this is going to be the cube root of, this is going to be 2 times negative x in parentheses squared plus 3. Now remember, if you raise a negative to an even power, it's going to be positive. So that's going to become then the cube root of 2x squared plus 3 when I simplify it. So h of x does equal h of negative x, so this is an even function. So it does have y-axis symmetry there. Now, if I want to verify that it doesn't have origin symmetry, we already know that h of negative x equals the cube root of 2x squared plus 3. H of negative x has to equal the opposite of h of x. So the opposite of h of x means to take the opposite of this function, which means the negative goes on the outside. This is going to be the opposite of the cube root of 2x squared plus 3. And notice that these are not the same thing. This is positive and this is negative, so they're not equal. So therefore, it does not have odd symmetry. It does not have origin symmetry. It's not an odd function. So again, I can tell from the graph, an odd function has to have origin symmetry. So if there's something over here, it's got to be mirrored across the origin. And I don't see anything over here. Same way over here. This graph part over here should be mirrored across in this region over here, and we don't see anything mirroring. So there is no origin symmetry there. So it does have y-axis symmetry, therefore it is an even function. And we also proved it because h of x does equal h of negative x, as we did so.